Welcome back to Talk Tensors.
Right.
We're going to be talking about something pretty fundamental today.
Yeah.
I'm really interested to get into this, so let's get started. We are diving into a paper all about evaluating LLMs.
Oh, yeah. Which is so important.
It is.
Especially as these models are getting, better and better.
Right. More and more sophisticated. We need good ways to,
To evaluate them, to know how good they actually are.
Actually figure out how good they actually are. And not just,
Not just be impressed by the fluency.
Yeah.
Or the human likeness.
Right.
But really dig down,
Yeah.
and be rigorous.
Are they giving us good answers?
Yeah.
This paper is called DAFE, LLM-Based Evaluation Through Dynamic Arbitration for Free-Form Question Answering.
Okay.
And So
we're talking about question answering.
We're talking about question answering.
With LLM.
With LLMs.
Yeah.
And it's a really interesting approach because...
Right form, not multiple choice.
Free form.
Not fill in the blank.
Right.
Just open-ended.
Right.
What do you think about this?
It's really tough because, there's so many different ways to answer a question,
There are.
And so,
If you're restricting the model to, an A, B, C, D, or, just a single word,
yeah,
then you're really missing a lot of the nuances.
you're not testing its true abilities. And I think that's a big problem with a lot of the benchmarks that we have right now.
I think so too.
A
lot of them are stuck in that multiple choice world.
Right. Like the MMLU, for example, is a benchmark, but it's a lot of, multiple choice questions.
Yeah, which are fine for certain types of evaluation, but yeah, it's not the whole picture.
Right.
It doesn't show you the full picture of what these models can do.
Especially when they're, we're using them more and more in conversational settings.
Right. Like chatbots. Right?
Yeah, chatbots, or, these agents that are,
right.
actually doing things for us.
Right.
So this paper, it goes into why the traditional automatic metrics are kind of failing now.
Okay. So give me some, what are those traditional metrics and why are they failing?
So the classic example is exact match.
Okay.
Which is literally does this answer, string match with the reference answer?
Yeah.
And you can imagine
It's never going to work, right?
That's never going to work.
Not with these models.
Especially with these LLMs because,
They can paraphrase.
You can paraphrase, they can use different synonyms.
Right. They can be verbose.
They can be verbose. They might even be more accurate in some cases.
Right.
Because they can add information that wasn't in the original reference.
Yeah. So even if they get the gist of it right, exact match is going to penalize them for not, word for word being the same.
Right.
So what else? What else breaks down?
So then there are the n-gram-based methods.
Okay.
Which look at sequences of words.
Okay.
And they try to, see how much overlap there is.
Right.
But there's still...
Like BLEU and Rouge.
Yeah, like BLEU, Rouge, yeah. They're still, they're not understanding the semantics. They're just looking at...
They're just looking at words.
Just looking at the word order and the words themselves.
Right.
Yeah.
So what if an answer, has the right meaning, but uses completely different words?
Yeah.
Those metrics would just say, nope, no good.
No good. Yeah.
Even though a human would be like, yeah, that's the same thing.
Right.
Right.
And then there are the neural-based metrics, which are, kind of like the newer kids on the block. And they're using things like, BERT embeddings.
Okay. So they're trying to get at the meaning of the words.
They're trying to get at the meaning. They're trying to compare the meaning of the generated answer to the meaning of the reference answer.
Okay.
But those still have some,
I imagine they still have some problems, right?
Yeah.
Because nothing's perfect.
Yeah.
So what are the issues with these neural-based methods?
So one issue is that they're very dependent on the quality of the reference answers.
Oh.
So if your reference answer is bad, then your metric is going to be bad.
It's garbage in, garbage out.
Yeah.
Yeah.
And they also have problems with domain adaptation. So if you train, your BERT model on one data set,
right,
and then you try to apply it to a different data set, it may not work as well. And then also they produce these continuous scores.
Right.
So it's hard to say like, okay, this is a good answer or a bad answer.
Right.
It's just like
is a 0.7 good? Is a 0.8 good?
Yeah, is 0.7 good? Is 0.8 good?
What's the cutoff?
And I imagine
like with all of these challenges, it becomes even harder when you're dealing with these very chatty, verbose LLMs.
Exactly.
that are designed to be conversational.
Right. And that's really where we are now.
Yeah.
We're not just trying to get LLMs to generate like short snippets of text anymore.
Right.
We want them to have like full-blown conversations with us.
Exactly.
So yeah, the traditional metrics are really struggling.
Yeah. So what's the alternative? Like, what have people been doing?
So I guess like the gold standard has been human evaluation.
Okay.
Makes sense, right?
Because we're the ones who ultimately care about whether these answers are good or not.
We understand the nuance. We understand the context.
Yeah.
But that's really expensive.
Yeah, I can imagine. Like getting a bunch of people to sit down and read through all these answers, it's time consuming.
It's expensive.
It's probably not very consistent.
It's not very consistent.
Because different people have different opinions.
Different people have different opinions, different biases.
Right.
Yeah.
So it's not perfect either.
Yeah, it's not perfect. No.
So what else can we do?
So the new wave is to use LLMs themselves as judges.
Oh, interesting. So use the AI to judge the AI.
Yeah, use the AI to judge the AI. And there's been some...
Don't like it.
Yeah.
Like it.
There's been some early work on this. There's like pairwise comparison methods where you give the LLM two answers.
Right.
And you say which one's better.
Okay.
There's single answer scoring where you give it one answer and you say, is this,
is good or bad?
Good or bad, relevant, helpful, whatever.
Right.
And so this paper, it's kind of building on that.
Okay.
But it's adding this really interesting twist.
Okay. I'm intrigued. What's the twist?
So they take inspiration from self-correction mechanisms.
Okay.
Which is where models use external feedback to improve their own outputs.
Right.
And so they thought, well, what if we give these LLMs that are acting as judges, a reference answer?
Ah, okay.
Yeah.
So they have something to compare it to ground them.
Yeah.
Yeah.
So they have something to ground them.
Okay. So that's how they're sort of training these LLM judges.
Okay. So they still want to leverage the LLM's understanding of language, but they want to give them but
also give them some guidance. Yeah.
And this is where their framework comes in, which they call DAE.
Okay. So DAE. Dynamic Arbitration Framework for Evaluation.
Yeah.
Okay. So tell me about DAFE. What's the big idea here?
So the big idea is that they use two primary LLM judges.
Okay.
And then they have a third LLM that acts as an arbitrator.
Okay.
But the arbitrator only comes in if the first two judges disagree.
Oh, interesting.
So
you're not always using three. You're only using three if there's a disagreement.
Right.
Okay.
And
I see. So that's kind of the dynamic part of it.
That's the dynamic part of it.
Yeah.
Because they want to balance like reliability and,
efficiency. Yeah.
So they don't want to always be using three LLMs.
Right.
Because that's expensive.
It's expensive,
right.
Computationally.
Yeah.
So that's really interesting. So the paper makes a number of contributions.
Yeah.
One is this DAFE framework.
Right.
But they also do a bunch of analysis of just the existing methods.
Right. They really thoroughly analyze
and how they break down
the traditional metrics. Yeah.
Yeah.
And they also, they have a section on evaluating LLM judges.
Okay.
And they have a whole, human evaluation setup as well.
Okay.
So let's dive into the methodology.
Yeah.
So how did they actually, do these experiments?
Yeah. How do they set it up?
So first, they had to get LLMs to generate answers.
Okay.
Right?
So they had a set of questions.
They had a set of questions.
And they had candidate LLMs generate the answers?
Candidate LLMs generate answers, yeah.
Okay.
And then they had other LLMs acting as judges.
Okay.
And they gave the judges the original question,
Okay.
the candidate's answer, and the reference answer.
Okay, so they have all the information.
Yeah.
Okay.
And the prompt that they used for the judges was really interesting.
Oh, okay.
Because they just said, you're a helpful assistant acting as an impartial judge.
Okay, so just zero shot prompting.
Just zero shot.
No fancy,
No few shot examples. No chain of thought prompting.
Yeah.
Just straight up.
Keep it simple.
Keep it simple. You're a judge. Tell me if this is good or bad.
Okay, I like it.
And
the verdict was just a true or false.
True or false, yeah.
Simple.
Very simple.
Yeah. And they asked for a brief explanation as well, right?
Yes, they asked for a short explanation.
Okay.
And then, so they had different LLMs for the different rules.
Right.
So for the primary judges, they used Mistral 7B and Llama 3.170B.
Okay.
And for the tiebreaker.
So one smaller model and one bigger model.
Yeah. And for the tiebreaker, they used GPT-3.5 Turbo.
Okay.
And they also did some, experiments with other models like GPT-4o and DeepSeek R1.
Okay.
But for their main experiments, they used
the ones you mentioned.
Yeah.
Okay.
And they also set the temperature of all the models to 0.
Okay, so that their outputs would be deterministic.
Right.
Yeah.
So it's reproducible.
Okay, so they had their models, they had their judges.
Yeah.
What about the data? What kind of questions were they asking?
So they used 5 different question answering data sets.
Okay.
AmbigQA, which has ambiguous questions.
Okay.
FreshQA, which requires up-to-date knowledge.
Okay.
HotpotQA, which is multi-hop reasoning.
Okay.
Natural questions,
okay,
which are real user queries.
Okay.
And TriviaQA,
okay,
which is trivia questions.
Okay, so a nice variety.
Yeah, a good variety of question answering tasks.
Yeah.
And they took a random sample of 300 examples from each data set.
Okay. And they compared DAFE to a bunch of baselines, right?
They did.
So tell me about the baselines.
So they had exact match.
Okay.
But they adapted it a little bit. So instead of requiring an exact string match, they just required that the reference answer appear somewhere in the generated answer.
Okay, so they made it a little bit more lenient.
A little bit more lenient.
Yeah.
They had BERTScore.
Okay.
But they converted it to binary.
Okay.
So they used a threshold of 0.5.
Okay.
They had geval, which is a reference-free evaluator that uses GPT-4.
Okay.
And then they also had human evaluation.
Okay, so the gold standard.
Yeah. So they had 3 NLP graduate students rating the answers.
Okay, and they were just giving a true or false, like the LMS.
Yeah, just true or false.
Okay. And they anonymized the model outputs.
Right, yeah.
So that the humans didn't know which model had generated which answer.
Right.
Okay, so they were trying to be as fair as possible.
Yeah.
Yeah.
And they also calculated inter-rater reliability.
Okay.
So they used Fleiss's kappa and percent agreement.
Okay, so making sure that the humans were all on the same page.
Yeah.
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 So what were the main results? What did they find?
Yeah, what happened? Did DAFE work?
Well, so first of all, the LLM judges, they were much better than the automatic metrics.
Oh, okay.
Like EM and BERTScore.
Interesting. So the LLMs were actually better at judging the LLMs than these traditional metrics.
Yeah. And they were pretty close to the human evaluation.
Okay, so they were in the right ballpark.
Yeah. And then DAFE, it was either as good as or slightly better than the individual LLM judges.
Okay, so it was at least as good.
At least as good.
Yeah. And they measured this using Cohen's kappa, which is a measure of agreement.
Okay.
And DAFE had near perfect agreement with the human judges.
Wow, that's impressive.
Yeah.
Yeah.
Even better than the other LLM judges.
Okay.
And they did run into this thing called the kappa paradox.
Okay.
On the TriviaQA data set.
Okay.
Which is where you have a high level of agreement, but the kappa score is low because of class imbalance.
Okay. So that's just a quirk of the metric itself.
Yeah. And then they also looked at macro F1 scores.
Okay.
Which is another way of measuring performance.
Okay.
And DAFE had consistently high macro F1 scores.
Okay.
Which means that it was really good at,
Identifying the good answers and the bad answers.
Yeah, identifying the good answers and the bad answers.
Yeah.
And they noticed that the larger models generally did better as judges.
Okay, that makes sense.
But there were some cases where the smaller models were just as good.
Okay.
And they also...
So size isn't everything.
Isn't everything.
Yeah.
Yeah.
It helps, but it's not everything.
Yeah.
Okay.
And they also noticed that EM, even though it had lower overall accuracy,
Right.
it actually had better instance level agreement with the human judges than BERTScore.
Interesting. So even though it was less accurate overall, it was more consistent.
More consistent,
Okay.
yeah.
Yeah, okay.
And they attributed this to EM's high precision.
Okay.
Because when EM says that something is a match,
Right.
it's usually right.
Wrong.
Whereas BERTScore, it can have more false positives.
Okay, so it's more likely to say that something is good when it's actually not.
Right.
Okay.
So yeah, that was kind of surprising.
Yeah, that is interesting.
Yeah.
So the analysis section goes into more detail about the strengths and weaknesses of using LLMs as judges.
Right.
What were some of the things that they found?
So one of the strengths is that LLMs are really good at recognizing semantic variations.
Okay.
So, if you say Salma Hayek or you say Salma Hayek Pinot,
Right.
the LLM knows that that's the same person.
Okay.
Or if you say, Nick Fury, Agents of S.H.I.E.L.D., and you say Marvel, the LLM knows that those are related.
Okay, so they understand the connections between things.
Yeah, yeah.
Um,
and they're also pretty good at taking into account all the different factors.
Right. They're looking at factual accuracy. They're looking at logical coherence.
Yeah.
They're looking at contextual relevance.
Right. So they're not just, myopically focused on one thing.
Right.
They're trying to get the big picture.
Yeah. But they also have some weaknesses.
Okay.
So one weakness is hallucination.
Okay.
So they can hallucinate reasons for their judgments.
Okay.
They can provide incorrect explanations.
And they can even reference criteria that weren't part of the evaluation.
Oh, wow. Okay.
Yeah.
So they're just making stuff up.
Yeah. That's not good.
And then they also have problems with false positives and false negatives.
Okay.
And this is often because they overlook critical distinctions,
right.
or they don't account for the level of specificity that's required.
Okay.
And they gave an example of Mistral 7B,
okay,
which sometimes just disregarded the ground truth.
Oh, wow.
Yeah.
Okay.
And then they also noticed that GPT 3.5 and Mistral 8x7B, they sometimes focus too much on specificity.
Okay.
Which led to more false negatives.
Okay, so it's a balancing act, right?
Yeah.
You want them to be specific enough, but not too specific.
Right.
Yeah.
And then they also saw some reasoning errors.
Okay.
So
in their explanation.
In their explanations, yeah.
Yeah.
So fabrications,
okay.
circular logic, overconfident assertions. Okay, so they're not always reasoning correctly.
Right.
Yeah, yeah.
And they also saw a verbosity bias.
Okay.
So they tended to rate longer answers more favorably.
Oh, interesting. Okay.
Yeah.
So just because it's longer doesn't mean it's better.
Right. And they had some problems with multiple reference answers and open-ended questions.
Okay.
Especially on the TriviaQA dataset.
Okay.
And then they also noticed some temporal limitations.
Yeah.
So they were evaluating on data that was mostly from, a few years ago.
Right.
But they still saw cases where the LLMs were misinterpreting recent events. Or terminology.
Okay.
And they gave an example of the Patriots-Dolphins game.
Okay.
Where the LLM hallucinated the date.
Oh, wow.
Yeah.
Okay.
And so they analyzed the disagreements between the two primary judges.
Okay.
And they found that the disagreement rates were higher on TriviaQA and FreshQA. And they said that this was actually a good thing.
Oh, okay.
Because it gave DAFE more opportunities to improve the evaluation.
Okay, so the more disagreement there was, the more DAFE could step in and help.
Right.
Okay.
And so they found that arbitration using GPT 3.5 Turbo, it really did improve the evaluation performance.
Okay.
It improved the macro F1 scores and the Cohen's kappa.
Okay.
Especially on ambiguity.
Okay.
And then the related work section, it it talks about the history of NLG evaluation.
Okay.
And it kind of traces the evolution from these simple string matching metrics
Right.
like EM, BLEU, Rouge,
Yeah.
to the more sophisticated neural methods.
Right.
And it kind of positions the use of LLMs as judges as a natural progression.
Okay.
Yeah.
That makes sense.
Yeah.
As LLMs get better,
Yeah.
we can use them for more things,
Right.
including judging other LLMs.
Right. And it also draws parallels between DAFE's arbitration mechanism
Yeah.
and traditional peer review.
Oh, interesting.
Yeah. So it's kind of like, you know,
Okay, face, and if they disagree,
you have a third review.
you get a third reviewer.
Yeah.
Yeah, that makes sense.
So yeah, that's kind of
So DAFE is kind of like a